In today's video, I'm going to finally get around to installing the alarm system in my new house. And as you can see here, like my flat, I've gone for a Texecom system. When it came to picking an alarm system, I wanted a sort of traditional, regular alarm system. I didn't want any of those sort of smart alarms, likes of Ring, SimpliSafe, any of those. I wanted a traditional alarm system like this, and then to make it smart, I can always add network modules later on. And then the reason I went for a Texecom system is just because I've used them before, and they've been absolutely brilliant, and they're extremely flexible and powerful. With these higher end Texecom systems, this is the Premier Elite series, you can basically expand it to sort of whatever you would ever need. For example, this is a completely wired panel, but if you ever wanted to add wireless devices, you can add a wireless zone expander to it and connect wireless devices. You can connect all sorts of network modules. If you want sort of app control through the Texecom app, you can buy their SmartCom module, connect that into the panel, and that will give you network control through the app. If on the other hand you want local network control through either Home Assistant like I'm doing or various other smart home systems, Control 4, that sort of thing, you can use network modules such as the Com IP or Com Wi-Fi modules to connect this to a local network. You can connect in sort of traditional phone dialers if you wanted to. You can connect in all sorts of weird and wonderful communicator modules to this. It's not your traditional plug it into Wi-Fi and use the manufacturer's app type device. It's an extremely flexible system. So here's all the parts we'll be installing. Obviously this is a completely wired system. All the wires are already pre-installed. So I installed the wires in the previous video. I think I need to run one more wire for the external siren and then a couple in the garage, but not many wires. Most of the wiring's pre-installed, but this is all the hardware we're going to connect to those wires. So what we'll now do is we'll go in and we'll sort of take a look at each of these devices or each of these types of device in turn, talk about what I've gone for, talk about why I picked that particular part, take a look at how we'll connect it up, and then once we've done that, we'll go away and get this installed. So now let's start off by taking a look at the panel. And this is the Texecom Premier Elite 24. Texecom do a bunch of different panels, and the main difference is the number of zones that they support. So the 24 supports 24 zones, 48 supports 48 zones, and so on. The 24 is their sort of entry-level panel. The only version they really do below this is the same thing, but it's plastic cased, which is possibly better for a home environment. But because this is going in my garage and I want to add a bunch of extra hardware into this potentially, I went for the slightly more expensive metal cased panel just to get the nicer casing, bit more space, bit more durable. So yep, it's the Premier Elite 24, and it's the metal cased version. Now, when I say the 24 defines how many zones this supports, that's how many zones this can support in total, not how many it supports on board. And that goes for all the Texecom panels. So it's important to bear in mind when you see a number of zones, check how many onboard zones it supports. Because this panel, I think, along with most of them, have 8 onboard zones, and then the 24 or the 48 number defines how many zones you can expand the system to using separate zone expanders or by connecting zones into keypads, which we'll take a look at later. The other thing to bear in mind is that the panels also differ in terms of the number of user codes, areas, and keypads they can support, not just the number of zones. So it's important to check the manuals and the datasheets to make sure you buy a panel that's capable of what you need. So for example, this one here, which is the Premier Elite 24, can support 24 zones, it has 8 onboard zones, it can support up to 4 keypads, 2 areas, and 25 user codes. So in terms of what each of those means, the number of zones defines the number of sensors you can connect to the panel. So a zone is roughly going to be a sensor, like each PIR is probably going to be its own zone. It doesn't have to be. You can wire it up to have, say, multiple PIRs on the same zone, and sort of older traditional alarm systems would potentially have that. You maybe have a downstairs zone with all your downstairs PIRs on it. But on these more modern systems that support a lot of zones, generally speaking, one zone is going to be one sensor or one door contact. And then as I mentioned, you have 8 onboard zones. That means there's enough connections inside the panel to connect 8 different zones into the panel directly. If you need more zones than that, you buy what's called a zone expander, which is an external box that will connect into the panel over the network connection. So it's a 4-wire network connection. The zone expander connects in, and then you can connect your additional zones to that separate device. The expander can either be directly next to the panel, or it can be in a completely separate area of the building, depending on how your building's wired. Next up, we talk about user codes. That's very simple. That's how many users and codes you can have on the system. So this one can support 25 of those. So that's going to be absolutely fine for a home environment, but potentially in a business, you may need more codes than that. The number of keypads is how many keypads you can have on the system. I'm going to have 3 keypads around the house. I'll have one at the front of the house, one at the back, and one in the garage. So this is absolutely fine having 4 keypads. Larger properties, you might need more than that. And then when it comes to areas are kind of completely separate parts of a building that are connected to the same alarm panel that you maybe want to arm and disarm separately. This supports 2 areas. So what that means is I'll have one area will be the whole house, and then the other area will be the garage. And that means I can have the garage armed when the rest of the house is disarmed. So if someone, say, broke into the garage while we're at home, the alarm would still go off, because even though the house was disarmed, the garage would still be armed. And then each area can have separate keypads, so the keypad in the house can arm the whole house and also the garage, and then the keypad in the garage will just arm and disarm just the garage. So that's what you have with areas. Of course, on top of areas, you can still emit certain sensors. So, for example, if I want to just arm the downstairs of the house or just arm the upstairs, various things like that, do sort of part arms, you can still do that within a single zone. You don't need to have a separate area for upstairs and separate area for downstairs. So that's kind of how the areas work. They almost give you completely separate alarm systems, but connected to the same panel. So that's the limitations of this and kind of the specs. Realistically, 24 was all I'm ever going to need. I'm not going to need more than 2 areas. I'm not going to need more than 4 keypads. Definitely don't need 24 zones, so there was no point getting a bigger panel, really. But of course, you could if you needed to. And that's us inside the panel, so let's take a look at it. So as you can see in here, there's a lot of empty space. Now, some of that space will be taken up by a battery, so of course you need your alarm backup battery. So that will kind of sit in the panel round about there and connect onto these wires, so the battery will take up some space. Other space in here is for things like wiring. You don't want to route your wires around. There's nice sort of cable tie areas, grommeted holes you can put grommets in to bring cables through, various knockouts, bits you can put zip ties on if you wanted to do that. But there is a lot of empty space inside this panel. The plastic version of this is a lot smaller, so that has a lot less room in it. So if you want a physically smaller panel to put in a tight space, the plastic version would definitely be better. But because I might want to install various network modules into this over time, I wanted to get the physically larger panel. So now taking a look at the important things inside the panel, we can see we have a power supply here, so you'll connect your mains into this and that will provide DC out to the PCB. The next thing you have up here is this tamper switch. And this is something that if you've never worked with alarm systems before, you probably might have not seen before. But essentially with burglar alarm systems, almost every single device you'll be installing has some sort of tamper switch, which means that if the cover is removed or it's taken off the wall, the alarm will sound. And that's what this does here. You can see there's this big switch here, that's under the screw hole, and when the screw is installed, it will push that switch down and trigger the switch. So that means if someone ever tries to take the front off the panel, the alarm system will go off. And it'll even do that if it's disarmed. You have to put the system into engineer's mode before you can start taking things apart without the alarm going off. What you also might notice is that you've got this tamper switch here installed in a piece of plastic, and under there is a screw hole on that same bit of plastic. And then if you take a look around the back of the panel, you'll see there's a big cutout here where that screw hole is. And again, this is part of the tamper mechanism, because when you install this, what you need to do is screw this to the wall through this hole, obviously put other mounts on as well, but you'll screw this part to the wall. And what that means is if someone ever tries to wrench the panel off the wall, because this is a weaker plastic area cut out of the metal, this bit of plastic will break off and stay stuck to the wall. And when that bit of plastic rips off, that will also rip out this tamper micro switch at the same time. That will then release the switch because it's no longer being pressed in by the screw, and the alarm will go off. It's what I quite like about alarm systems. There's always really clever little things in the hardware, lots of little clever mechanical design to make these sort of things work. So yeah, that's how the tamper works there. Next up we have the PCB here. I'm not going to go into a huge amount of detail on this yet. I'll kind of talk about that later when we're actually wiring it up. But just to give a rough summary of the connectors we've got here, obviously you've got power in, this is for the battery connection, these are for the bell, so the outside siren. If you've got multiple sirens, you'll just connect them up all to this. This plus minus T and R are network connections. So this is for a digital bus that will connect devices such as zone expanders and keypads. So they'll all connect into this. Next up, you've got OP1, which is a programmable output. So you can program the panel to trigger that output on various events, and that could trigger other systems. It's just a sort of switched negative DC connection, really. A speaker connection, you've then got your 12 volt positive and negative. That will connect to almost all of your devices around the system. So all your PIRs, all those sorts of devices require 12 volts. So they'll all connect to that to get 12 volts power. Aux fault, don't know what that is. You've then got all your zone inputs here. So there's 2 different terminals for each zone. We'll talk about how that works later and how it works out what's happening with the zone, but you've got 2 terminals for each of your zones, up to 8 zones. Next up, you've got these 2 white connectors here, and these are COM ports, and they're literally just TTL serial ports with a 5 volt logic level. They also have a 12 volt power supply, so you can power modems and things like that. But with these, you can literally program these panels with literally just a USB to TTL serial adapter with a 5 volt logic level. You connect that to these COM ports and you can program the system. These are also they're meant to be used for the various network modules. So if you've got a COM IP, a COM Wi-Fi, a smart COM, any of the kind of network modules, they'll connect over these serial ports. Now for my setup here, I might buy a proper COM IP module if it would be a bit neater, or I might use this beauty that I built for my previous Texecom panel, which is literally just a really cheap little 2-channel UART to Ethernet adapters. This is literally 2 UART serial ports with a 5-volt logic level, and this will share them out over Ethernet. And then from that, I can integrate this with my home automation system and all that kind of stuff using this little adapter here. I made a video about this if you want to see it previously. So this goes to two separate connectors that would connect to each of the COM ports on the panel, and that would allow me to both integrate this with my smart home system to get events from the alarm and all that sort of stuff, and also control it, and also allow me to use the programming software to program the alarm from a Windows laptop. Then there's this little box hanging off this. This is just because these COM ports output 12 volts to power the various connected devices. This device requires 5 volts, so it's just a little cheap 12 volt to 5 volt DC to DC converter. This is a bit bodgy. I might use it, or I might buy a more polished solution, but we'll see. If you're interested in seeing this, I made a video about how I built this previously. But yep, that's what we connect into the COM ports. That's really most of it. You've then got this DigiModem port here. This is for their kind of traditional, more phone dialer type modems. They're kind of separate boards that would slot into that, and then that would connect up that way. But what you can also do is you can actually get an adapter for this that gives you a third COM port like this, so it gets a little board that goes in that gives you another COM port if you want that. Finally, Digicom outputs, that's kind of just more programmable, just binary logic outputs that you can use to connect to various communicator modules to send signaling from the alarm. So yeah, that's most of the inside of the panel. There is, however, one issue with this panel that's not really a problem with it itself, but it's just something that I didn't realise before I bought it, and it's going to make me need to change my plans slightly. Because my original plan was to connect all the cables to this in steel conduit on the wall. And then to power it, I've already got a fuse connection unit on the wall, and it's going to come straight out the top of that in steel conduit into this grommet, into this hole on the bottom of the panel. The problem with that is it turns out this panel doesn't actually sit flush to the wall. Instead, it actually stands off quite considerably with these little feet on the bottom. And even though it looks like you can maybe take these feet off, there's various screws and other parts protruding from the bottom, so you couldn't really. It needs to stand off the wall on these feet. Now that's not a huge issue, but basically what it means is I won't then be able to bring steel conduit straight down the wall and into the top of the panel, because with any kind of sort of standard saddles you'd have for conduit, the conduit would just be too close to the wall to go into these holes. Now of course the correct thing to do would be to bend an offset into the conduit, but I don't have any sort of conduit bender, and it's not like in the US where the conduit's quite flexible and you can get a very cheap simple bender to bend it. The conduit we use in the UK is extremely rigid, and you need very expensive kind of frame type benders to bend it, and I'm not going to spend hundreds of pounds on one of those for this one project. So we'll take a look at how we're going to mount it later. I've got a plan and it'll be absolutely fine, but we'll take a look at that in a minute. But yeah, just something to bear in mind, if you are planning on mounting this, it does stand off the wall a good centimetre or so, if not even more. You can't just mount it completely flush to the wall and very easily run conduit in. You need to bear in mind it does stand off a little bit. The next hardware we have is the keypads, and as you can see, I've gone for 3 of them. The plan here is to have one keypad by the front door that's used for most stuff, for entry and exit, just general stuff lobbied on through the front door keypad. I'll have one keypad at the back door, just so if I ever need to come in and out through the back door, I can still unset and set the alarm from there. Otherwise you'd have an issue where if you're to come in the back door and then go into the kitchen, because of the PIR in there, it would immediately trigger the alarm. So I'd rather have a keypad by the back door just so I can easily unset the alarm from there. The third keypad will then go in the garage, because I want to arm and disarm the garage as a completely separate area, so I want to set up so if I go into the garage, the alarm will be armed, I'll get a countdown, I'll be able to use a keypad in the garage itself to disarm the garage, so that's what the third keypad's for. Now as you can see, I've gone for 2 different types here. The one on the left here is one of their flush mount decorative ones. These are hideously expensive. This was probably about £150 or something. They're really expensive, but it's a really nice sort of gunmetal finish, they call it. I mean, it's just a very dark, shiny material really. It kind of matches the sockets and switch they'll be installing, so it'll look quite nice. And it mounts flush to the wall as well, so it'll just look really, really nice. I went for one of these in the flat, although it was a white one, and it does just look a lot more premium, a lot nicer to have in your house, to have a nice plastic one, a nice metal decorative one rather than a cheap plastic one. So that's going to go in the hallway for the front door, because that's the room that people are going to see. As for the one in the utility room at the back door and then the garage, I don't really care about how they look, so I've just gone for the cheap plastic ones because I wasn't spending £150 on each of these. So these are just basic plastic ones, so they're exactly the same sort of thing. Screen on the front, this is a smaller screen. They do ones with a larger screen, but they're more expensive. Flip down panel, various buttons. It's a much cheaper, much simpler option. And I've got 2 of these. And now here we are taking a look inside one of the keypads. I'm just looking at one of the plastic ones just now, but they're all exactly the same inside in terms of wiring. What you've got is a bunch of connections. You've got the network connections, which is the same as we saw on the panel. So you just map these one to one from here back to the panel, And if you've got multiple keypads, you can either wire them in a chain, or they just all wire in parallel. So you can do it either as a star from the panel, or you can like daisy chain your keypads. It's up to you. I think there is maximum lengths of how long a cable can be on the network, and maybe how many devices you can daisy chain. But yeah, it's just kind of a sort of star configuration, really. So yep, that's network there. So that's how it gets a sort of digital connection. There's another programmable output. So again, you could have your keypad trigger some sort of programmable outputs. And then the final connections here are really useful, which are these two zone connections. So much like the zone connections on the panel, you can connect two wired zones to each keypad. So in my setup here, I'll be wiring door contacts from the neighbouring doors for these keypads directly into the keypads. It just saves a lot of cabling because you don't need to run a cable from each door all the way back to the panel. And it also saves on those keypads, on those panel zones, because you've only got 8 panel zones. So it makes sense to kind of use the ones at the keypads if you've got them. Additionally, in my kitchen, I'm going to be installing a glass break sensor. We'll take a look at that in a minute. And I didn't plan for that when I first ran the cabling because it was very much an afterthought. But because this keypad will be installed on the other side of the wall from that glass break sensor, I can very easily wire that sensor into the zone on this keypad rather than needing to try and get an additional cable all the way back to the panel for that new sensor. So it's really, really nice to have these. Now you'll notice here that the zone connections on the keypads have 4 terminals each rather than 2 on the panel. Now this is a difference between how you can wire alarm zones, and it's how it's been done traditionally versus how modern alarms do it. We'll talk about this when we look at the PIRs because it'll make a lot more sense there. But you do have 4 terminals here. It comes down to how you wire the zones up. You can also wire the zones to this in the same way that you do on the panel by only using 2 of these terminals. So we'll talk about that in a minute because it's a fairly complicated topic. But yep, that's inside of one of the keypads. The only other thing of note here is you've got yet another tamper switch, so another little micro switch there that presses on at the back of the case. And like before, you've got this piece here that you would screw to the wall. This presses in at that micro switch. So again, if the keypad's ripped off the wall, this bit of plastic breaks out, releases the micro switch, and the system goes into tamper. Only other thing of note in here is you've got these little dip switches here to set a keypad address. So each device on that network bus needs to have its own address. So you use these little dip switches here to set an address for each device, just to give it an address on that bus. So yeah, that's what you have there inside a keypad. Next up, we have the PIRs we're going to be using. And as you can see, I've got 2 different types. So I'll get rid of the sort of duplicates. We'll just take a look at one of each type of PIR. Now, the first PIR I've gone for most of the rooms is the brand new Texecom Capture Pet. And this is a new PIR they've released that's designed to be more pet immune than their other PIRs. I think. It's a little bit confusing. So they launched this one fairly recently, advertising it as super pet immune and suitable for large animals and all that kind of stuff. But all of their previous PIRs from the Capture range, such as the P15, also have a pet-wise mode you could manually enable with a little switch inside it. And that said it was suitable for animals up to a reasonable weight and things like that. So I contacted Texecom and asked what the difference was between the Capture Pet and buying just their P15 PIR and enabling pet-wise mode. Very helpfully, their support came back and quoted the press release for the Capture Pet that I'd already received in my inbox and nothing else, so that was very helpful, thanks. So still don't actually know how this compares to the other PIRs. If anyone in the comments actually knows, I'd be interested to find out. But the Capture Pet specific ones weren't much more expensive than getting the regular P15 PIR and enabling pet-wise, so I thought I may as well go for this. Just because even though I don't currently have a pet, might get a dog in the future, and we also fairly regularly dog sit, and it's nice to be able to set the alarm if there's a dog in the house without having to worry about it. And it'll be interesting to see if this actually works, because previously in my flat I had pet-safe PIR from Texecom, but they were an older model. They were the older Ricochet wireless ones from before the Capture range came out. And they were apparently pet-safe, but we were dog sitting and he did manage to set it off. Now admittedly we checked the cameras and he'd been jumping on the bed in front of a PIR, so maybe that's why it went off. You know, they're generally more designed to stop dogs at like ground level, not jumping on the bed. But hopefully this will work a little bit better. Of course, at any rate, before I randomly arm the alarm with a dog at home and then go out and let it annoy all my neighbours, what I would do is I would initially leave a dog at home with the alarm disarmed and then check the logs and see if the alarm if any sensors were triggered by the dog before I actually trust it. So be interested to test that out and see how pet immune these actually are. But yep, these are the new Texecom Pet PIRs. We'll take a look at that in a minute. The next one we have is this new one here, which is the CA, again from the Capture range. And what this is a ceiling mounted PIR. And this is going to go in the garage. Now, the reason for that is the garage is obviously a fairly big open space, but there's racking down one wall, there's various stuff stored down the other wall. There's basically nowhere in the garage I could safely put a PIR and say that it would never get obstructed by something being stored in the garage. So it makes more sense to put a ceiling mounted PIR right in the middle of the garage, and that way it'll never really get obstructed. Now, this particular model I've gone for here is one of their higher end ceiling mount PIRs because it's a dual tech PIR. What that means is that not only does it use infrared with a PIR element, it also uses microwave to detect motion. Now, what that means is that in addition to using a PIR to detect the heat of a person moving past, it also uses microwaves to detect the presence of a person. And both of those have to trigger before this will trigger an alarm. So it has to both sense the heat of a person, and the microwave element also has to detect a person before it will trigger an alarm. And that feels fairly sensible to put in a garage because an infrared PIR detects heat, garages can be a bit drafty, potentially there could be the boiler in the garage turning on and off, lots of sort of heat and various drafts moving around in the garage, and I don't want to risk false alarms. So a dual tech PIR makes a bit more sense in the garage because it's a bit less predictable thermally. So having that dual tech PIR should hopefully reduce false alarms. So be interested to try this out. It's also quite interesting that this is their ceiling mounted model, but it is literally just the same case as their normal PIRs, but with a sort of screw-on ceiling mounted cover. Now this is a specific ceiling model. You can tell the lens on this is slightly different to the regular wall mounted PIRs. It's just kind of interesting that they've enclosed it in the same body. But I suppose that actually makes a lot of sense because it works, it looks fine when it's up, and that probably saves an absolute ton on like plastic moulding and manufacturing. So yeah, it's quite a clever design that. So yep, that's a PIR that'll be going on the ceiling in the garage. Now, one question that's kept coming up when I started installing all the alarm cabling was people talking about why I'm not installing human presence detectors, or saying, oh, on those alarm cables, install microwave human presence detectors, not alarm PIRs. Now, the reason I'm not doing that is because when it comes to PIRs designed for an alarm system, there's a lot of standards and regulations and compliance that these have to go through that sort of human presence detectors that are designed for home automation don't. If you've say got a sensor that's designed for human presence detection, it's designed to say turn lights on and off, if that accidentally triggers occasionally, that's not a big deal. However, something like a PIR, if that's going to trigger the entire alarm system, set off a whole load of alerts, and potentially in some commercial places call the police, things like that, you definitely don't want something that can accidentally trigger. So when it comes to the PIRs that I want on my alarm system, I want to go for proper, accredited, trusted, certified PIRs that are designed for security use. And if I want human presence detectors for home automation applications down the line, I can always install wireless Zigbee sensors down the line. But I don't want to be relying on those sorts of sensors for my security system. Especially when it comes to human presence detectors, they can quite often say see through walls with microwaves, things like that, which is why you'll never get a microwave only alarm PIR nowadays. They're always dual tech, where it has to both sense infrared and microwave before it'll trigger the alarm. Whereas human presence detectors are just microwave only usually. So yeah, that's why I've done that. So yep, we're going for these PIRs and connect these up to the panel. So what we'll now do is we'll pop open this PIR here, which is the capture pet, just see what's inside. And we'll talk about the wonderful world of alarm wiring. So now let's pop one of these PIRs open and take a look inside. So what's really nice with these new ones, because I've used previous Texecom ones, is they're actually really easy to open. So there's a little screw on the bottom, but you don't need to actually unscrew it, it's just like a quarter turn to turn it. And then what happens is the whole PIR slides down from the base, it'll be screwed to the wall, and then the entire PIR itself lifts off and leaves just this little piece on the wall that's got no PIR element in it, which is really nice because it means that there's no exposed PIR. You're not taking the front off and exposing the actual PIR sensor itself. It's all completely self-contained on this. You do all your wiring here, and then this just plugs on. It also means that in the future, if you say you put the pet one in, you wanted to swap it for a different one, or you didn't have a pet safe one and then your pet kept setting it off and you wanted to swap it for this, you could theoretically just take the sensor off, swap a new one on, and not even have to change the wiring. It's a really clever design, this one. So first of all, if we take a look at the back of the PIR, you can see there's various contacts here. These will just kind of plug into this connector block here. Now, one thing that's worth noting here is, as you can see, the wiring, which I'll talk about in a minute, is all written on here. Now, if you look at the back plate here, you'll see the wiring is it's printed on the back of the PIR in the same order as the back panel if you look at it from the same direction. So it's not like 0 volts is this pin and our LED is this pin. It's actually mirrored. They've kind of mirrored it so you can take this off and look at it and it matches like that, which to me makes a lot of sense actually. Then on the back of the PIR, there's a couple of dip switches here. The one on the left lets you turn the LED on and off, so whether you want it to light up when it senses motion or not. I like having that on, but if it's say in a bedroom and it bugs you with it lighting up, you could turn it off. And then there's the other dip switch here. that on the pet model switches between big dog and small dog, which is basically a sensitivity adjustment. And what this sort of line with a plus is also saying is that if it's on the bottom position for small dog, you don't do anything. But if you put it up to the big dog, you also have to slide this little shutter here down so that, or up, so that the dog there appears in the window. And that's moved a little sort of lens in front of the lens, a little element, and that adjusts the pickup pattern to make it less susceptible to larger animals. So you can kind of adjust sensitivity on that. On the other hand, the ceiling mounted PIR has a lot more options because it's a dual tech PIR, so you've got the option to disable and re-enable the LED, various things about sensitivity, whether you want it to be dual tech, whether you want to enable cloakwise, which is a setting for if people are trying to cloak their presence, it'll detect that. I'm not going to go into detail on these, I would really need to read the manual, but this, because it's a dual tech PIR, has a lot more options, and it also has an adjustment for the microwave sensing, so you can adjust how sensitive that is, because microwave sensing can sometimes see through thin walls, things like that, so you want to be able to adjust that. So different PIRs will have different adjustments, and you really kind of just need to check the manual for each PIR to work out how to configure them. The final thing you'll see inside the PIR is this switch here that has a bunch of different resistor values next to it. And this is where we're going to have to explain how you kind of wire alarm systems and the two different ways of wiring them. So as you can see, if we look at this key here, it makes a little bit more sense. It labels all the different contacts that are on the terminal block here. And you have two contacts labelled alarm and two contacts labelled tamper. So when it came to very traditional alarm systems, what you'd have is essentially a loop for the alarm and a loop for tamper. So what that would mean is you have a piece of wire that would come into the alarm connection on a sensor, come back out of that, go to the next sensor, back out of that, and so on, and then loop back to the panel. And you do the same for the tamper. So you'd have this big loop of cable that would loop through each sensor and back to the panel. And then each sensor would be normally closed, so when there was no alarm, that wire would be connected all the way through. And if any sensor on that loop, say detected an alarm state, it would open its contact, break that loop, and the panel would detect it. Same for tamper, if any sensor on that loop was, say, ripped off the wall, or the cable was cut, again, that tamper loop would break, and the alarm would sense it. That's kind of a traditional way of wiring an alarm, and if you've got an alarm that's already wired, that might be how yours is set up. You might have a cable going from your panel to the first sensor and then looping through all your PIRs and then back to the panel. That's absolutely fine, but it does just mean that all of those sensors would have to be on the same zone. So that's a very traditional way of wiring a system, and if you want to do that, you would switch this little slidey switch up to this O/C connection for out of circuit. I think that means out of circuit. And then that would basically work like a traditional system. You'd have your alarm loop connected to the alarm, your tamper loop connected to tamper, and that would work. And this is why on that keypad, it had the 4 terminals, because once again, you had 2 terminals for the alarm loop and 2 terminals for the tamper loop. But nowadays, that's not really how people wire alarm systems generally. Generally, they're wired in what's called an end-of-line configuration, which you can see there by EOL. The way that works is you'll have 2 wires going to each sensor. They'll just connect into the sensor, and then the way the sensor will tell the panel whether there's an alarm condition or a tamper condition or everything's okay is by changing the resistance across that wire. Now, with traditional PIRs, you wouldn't have this nice little switch. You would just have a bunch of contacts like this, and it would just be wired to 2 different relays, one for alarm, one for tamper, and when either of those relays opened, it would break the circuit. And if you wanted to wire one of those for end-of-line configuration, what you would need to do is manually install resistors into the various terminals in the correct sort of wiring diagram, so that you essentially, when an alarm condition happens or a tamper condition happens, the correct set of resistors would be put across the 2 wires going in, and that would send the correct resistance down to the panel. I've wired a system like that and it was completely fine. It was a Texecom system. It was just before they launched this new capture range. But now with the new capture range, they make it a lot easier, because instead of having to manually stick resistors in and figure it all out yourself, they give this little switch here that lets you pick between a bunch of resistors that are pre-installed in the PIR. Now, the reason you need to pick different values is just different brands of alarm system expect different resistors. So 2K2 and 4K7 are what Texecom expect. So it's a 2K2 resistance means it's a tamper, and a 4K7 resistance indicates that it's an alarm state. That's what Texecom alarms expect. I think the lower end Texecom Veritas alarms actually use a different set of resistors, so you need to check your alarm panel's manual to work out what resistance it expects, but you can basically switch this little switch up and down to pick whatever resistors you need for your particular panel. I suppose there's also nothing stopping you putting it up to OC, not using any of the built-in resistors and then manually putting resistors in here. I can't see why you couldn't do that, but equally don't quote me on that because I've never tried it. But yeah, that's how this works with resistors. So with this, we're just gonna leave it on 2K2 and 4K7, and then when we wire the connection to the panel, we'll have a 12 volt connection going into positive and negative here. And then as we can see on the wiring diagram on here, all we'll do is we'll wire the two wires between A and D for the end of line configuration, and that will set the appropriate resistance down to the panel, which can read it and determine what's happening with the sensors. So hopefully that made sense. I'll show actually wiring this up later, but yeah, hopefully that kind of made sense as to how you wire these up. If you're still confused or you want more information, there's a lot of videos on YouTube going into full detail on how to wire alarm systems and all the ways of doing it. But yeah, that's kind of how I'm going to be doing it here. If you're trying to retrofit this into an existing system that's already wired, you might need to figure out how yours is wired and get a bit creative. If you've got an older system that's wired using sort of traditional loops, but yeah, that's kind of how that's going to be wired up. While we're on the topic of wiring, the next sensor we have is this, which is a glass break sensor. This is the Premier Impact glass break, and this is, I'm interested to try this out. I've never used one of these before. It's an acoustic glass break sensor. So essentially it's just a little microphone that sits on the wall, and if it senses the sound of glass breaking, it will trigger the alarm. My plan is to install this in my kitchen because I've got very large patio sort of French doors out the back, and if someone was going to break in, that's what they would probably do. They'd probably try and break that glass. So of course there's a PIR in the kitchen, but the idea of having something like this means that if someone even tries to break the glass, as soon as they break anything, this should set the alarm off and scare them off, rather than having to wait for them to actually be inside before any sort of PIR would trigger. So this little cover comes off the front there, and there's a screw under there I'll need to try and take out, and then we'll take a look inside of this. So now here we are inside the glass break sensor. If we open that up, as you can see, you've got a little microphone there. There's then a jumper here that lets you pick between plate and tempered glass or laminated/wired glass, so you can kind of pick between what type of glass you've got to kind of tell what this should be listening to. An option there that I think is to turn the LED on and off, because it'll have a couple of LEDs, and then a sensitivity adjustment here to adjust how sensitive it is. And then once again, you've got a tamper switch there to detect if the front's removed, and what I think is a test button there. And this is why I wanted to show this right now, right after we've talked about the wiring, because this is an older device and it's from before they launched the capture range with those switchable resistors. This is more of a traditional device. So as you can see up there in terms of wiring, you've got an alarm connection there, and you've got a tamper connection, and then you've got your standard 12 volts. So you'll put 12 volts into this, but for alarm and tamper, these are just essentially like relay connections. Now, I can't see any physical relays inside this, so it's probably using some sort of integrated circuit to actually do the switching here. But essentially, when there's an alarm state, so as standard, the alarm contacts will be connected together and the tamper contacts will be connected together. And if there's an alarm state, the alarm contacts will break. And if there's a tamper state, the tamper contact would break. So this is kind of designed more for a traditional loop system. And this is what you'll find on most PIRs. The capture ones are quite unique for having those switchable resistors. So with this, I either could wire it up using a loop, so I could just have 2 wires go to tamper, 2 wires go to alarm, and wire them back to the keypad. Or if I want to wire this in end-of-line configuration, which I probably would do just to keep things consistent, what I would need to do is then manually install some resistors between the various contacts here in the appropriate layout. I'll need to try and look up a diagram or figure it out from memory. But I'll need to install a couple of resistors inside the sensor, then run my 2 end-of-line wires into it, and that would work fine. So we'll try and take a look at that. I'll try and wire this up for end-of-line just to show you how that's done, because that's generally what you'll do if you're installing a PIR on an end-of-line configuration. It's not one of these new Texecom ones. But yeah, that's kind of more a traditional device and how you'd wire it up. The final sensors I've gone for are the door contacts. So I'm going to have one set of door contacts on the front door and one set on the back door. Now, the idea with door contacts is you ideally want them on any kind of door you're going to be entering or exiting from, because that way when you open the door, the alarm can sense that you've opened the door and immediately start a countdown to let you unset the alarm. What I also really like about the Texecom alarms in particular, and I suppose other brands can probably do it as well, is rather than just giving you a countdown to exit, you can configure the Texecoms so that you arm the alarm and it'll wait for you to open the door and then close the door again, and then it will arm. So you're not having to either rush out the house within a time limit or wait ages for the timeout to end to check it's set. So that's why I want to use door contacts. I could have just used a PIR to sense me coming in the hallway and then have that trigger the countdown, but that wouldn't allow me that nice entry and exit, so that's why I want door contacts. So I've gone for these ones here. They're not Texecom, they're Night Fire and Security products. I don't even know if Texecom do basic wire door contacts are such a cheap commodity device, because with alarms, I'm buying using all Texecom hardware. Apart from these, you don't need to, you can mix and match stuff very easily. But yeah, these are quite nice ones. We'll take a look inside now and see what's inside these. You can definitely get much, much cheaper ones that are a bit cheap and nasty. They're kind of just really basic screw terminals on the bottom of it. They're a bit nasty. So I went for a slightly higher end one that's a bit nicer inside. So this one here, as you can see, you've got a reed switch here. That will make contact with this magnet that's in here. And the idea is that reed switch will detect if the door is open or closed based on that. Interestingly, this has a bunch of other stuff as well. It's got another reed switch here. This is a grade 3 door contact, so it's a higher security grade than most sort of commodity door contacts. So it's got another reed switch here that I think is maybe to detect if someone's like holding a magnet around it inappropriately to try and trick it. It's got a kind of detection thing there for that. But yeah, it seems like a pretty decent door contact. And then in terms of wiring, once again, you've got tamper and alarm. So you've got 2 terminals for tamper, 2 terminals for alarm. And you could wire it again with sort of loop, that kind of traditional configuration, or you can do end of line wiring. And what's really nice with these that I didn't even realize until I literally opened the box, I just ordered them, didn't even notice they had these, is like the Texecom Capture PIRs, these actually have built-in resistors. So you don't have to, normally with door contacts, you'd have to again put resistors in like you'd have to do with that glass break sensor. With this, you can actually pick resistor values using these jumpers here. And then that means you don't actually need to ever worry about sort of sticking resistors inside this. Now, for this, it's obviously a slightly different setup to the Texecom Capture PIRs, but again, it comes with a little manual that goes into pretty decent detail explaining how it all works, shows how to wire it all, like that. And then on the back, it gives you the resistor values. So slightly different layout to on the Capture PIRs, but again, it just says various resistor values for end of line and alarm, various brands of alarm system and what resistor values they expect, and it tells you for each resistor value what jumpers to set. So for a Texecom alarm there, 2K2, 4K7, I need to put jumpers B and C and 2 on. So I set those jumpers over here, and that would mean that the correct resistor values would be sent over, set to these terminals when the alarm triggers. And then for end of line wiring, you would connect, you would connect between the leftmost terminal and the rightmost terminal. So yeah, that all makes sense. The other good thing with these is these are so easy to test because it is literally just resistors. You can stick a multimeter across it, move the magnet, and see what happens. It's pretty easy to do. So yeah, that's door contacts we'll be using. And then like all the other devices, the door contacts have a little spring there, they're pressing a switch, so if the top's ever removed, the system will go into tamper. Yep, all these devices have the same thing. Even the Capture PIRs, I didn't show this previously. Same thing, they've got a little switch on the back, hidden in there, that's pressed down by a bit of plastic on the case. So if you remove the PIR from the case, alarm goes off. Unlike the panel, this bit here is weakened, so you screw this piece to the wall, and again, that's a sacrificial bit of plastic. If you rip it off the wall, it'll break out and go into tamper. So didn't show that before, but yeah, they've got tamper as well, as do the door contacts. So yep, that is the door contacts we're going to be going for there. And now finally, we have the last component before we go away and install this, and it's the outdoor siren. Of course, there's a lot of different brands out there. You can mix and match them if you want, but here I've gone for the Texecom Odyssey X, which is their sort of new, well, not new, it's been out for years, their sort of standard, latest, high-end outdoor siren. And when you buy the Odyssey X, it comes in 2 separate parts that you generally need to order separately. Some retailers do also offer them kind of bought as a single item you can order, but generally speaking, they're sold as 2 separate parts, where you separately buy the internal module and the external cover. And you can buy the external cover in various colours. You can get black or white, and in various colours of this kind of clear piece, and you can get it in both this shape, or you can get a traditional rectangular shape if you prefer. So it makes sense kind of selling them as separate parts. You can carry different stock, you don't need to manufacture all these different things. And it also means if you say had one that got a bit grotty and you wanted just to change the cover just to freshen it up, you can change that without actually changing the internals. When it comes to the internals, there's a few different versions. They do a wireless version if you want to go down that route, or they do the wired versions, and then when it comes to the wired versions, you get ones with either a single sounder or one with 2 sounders that would be a bit louder. I've just gone for the single sounder one here, that would be fine. They also do backlit and non-backlit versions. This is the backlit one, which basically means there's a row of LEDs down here that lights up into this, and it lights up the entire front of this, which I really like. If you don't want that, you can go for the non-backlit one that just doesn't have those LEDs. Or you can just disconnect these LEDs if you don't want them. There's just a wire in there you could take out if you didn't want them. So yeah, we'll take a look at installing this later, potentially, although I will be very high up a ladder trying to install this, so the filming might not be great. But yeah, so that'll go up on the wall. In terms of wiring on this, fairly simple. You've got a bunch of terminals here for strobe, tamper, and bell. So you'll have one wire will trigger the bell, one wire will trigger the tamper, and one wire will trigger the strobe. You then provide 12 volts and 0 volts, which are already sort of piggybacked on these wires here that do the LED strip to light it up. So you kind of just take your 12 volts and 0 volts in sort of in parallel with those. So yeah, you'd wire your panel that down to your panel with those terminals there. Next up in here, you'll see obviously there's a transformer that I presume will be for the strobe. There's various circuitry down there for the strobe. And then there's a battery, so it's a rechargeable battery. The idea of this is if the panel was to ever die or someone's like disconnects cuts the cable to the siren itself, this can power itself and alarm without needing any power from the panel. And this is why if there's ever a power cut and you hear a bunch of burglar alarms going off, what that is where people haven't serviced their alarms. So obviously the mains power to the panel's dropped off, the battery inside the panel's failed, so the panel isn't being powered from the battery, so their alarm panel is completely dead, and therefore it's the external sirens that, because they've lost that power from the panel, these have automatically triggered from their internal batteries. So that's why alarms tend to go off in a power cut. And then also as part of that there, you've got this screw that you can push out, and that just presses against the walls. The idea is kind of lets you brace it against an uneven wall, so when you screw this down, it doesn't, snap out because the screw tightening in. You can tighten that screw down, and then this screw here will sort of keep it off the wall and keep it flat. So, yep, that makes sense there. There's then a couple of jumpers here to configure it. So you've got one left here one on the left for turning the battery on and off. So obviously that's set to off. If you turn that on, it might end up going off because it's probably still got a bit of battery charge. SAB and SCB and LC. These last two are designed for low current mode essentially. So SAB versus SCB, can't remember which is which, but one of them draws most of the current from the alarm panel, the other one draws most of the current from the internal battery, and then LC is low current mode. The idea for that is if you've got multiple sounders on the same system and you've potentially got too many and it hits the current limit for your panel, you might need to adjust those to limit the current that each sounder can take. It might run a bit quieter, but you might need to do that if your panel doesn't have enough current capacity to drive all your sounders. In my case here, I won't need that because I've just got the one, so this will be absolutely fine. So I think that's everything. Only other thing here is in terms of like mounting it and installing it. The way it looks like you're meant to install this is you'll bring your cable in the back here, and then you won't bring the actual outer insulation of the cable into here. You'll strip the cable back, and then each of the individual wires, I suspect, must feed through these little slots. And then when you close that up, that will all press together against this seal and give it a decent watertight seal. So I suppose that makes sense. We'll figure out how that works when we actually go and install it. And then to mount it, you've obviously got a screw hole there, and then these two really nice sliding bits here that you can kind of screw to the wall and you can kind of slide it up and down to get it nice and level. So these are absolutely brilliant to install. Be interested in installing this so high up a ladder, but yeah, that should be good. And then the final part we have is the cover. So what I really like about these Texecom covers are really, really nice. So this will install onto that, hinge down, works really easily. You can lift it up to service, put a screw in the bottom, secure it on, all dead easy to do. But what's really nice with these Texecom covers is they're very easy to brand. So with most alarm covers, generally what you have to do is if you want your branding, your company name or logo or whatever on the front, you kind of have to basically commission them explicitly from the manufacturer, apply for them, and probably order large quantities at reasonable cost. They're not the sort of thing you can really just do if you just want to brand one or two alarms. Maybe you're doing it yourself, or you're an electrician that occasionally installs alarms that you want to put a company name on it, but you don't want to order hundreds of covers. These Texecom ones are absolutely brilliant because, as you can see, it looks like, it's got an area here that's clear, and if you flip it over, you can actually pop that out. So that pops there. It makes horrible squeaky plastic noises when you do it. I'll do it off camera because I don't want to risk breaking it trying to do it at a funny angle. But yeah, that's now released, so that will then come out, and what you then get is this piece here that's like a diffuser for the light, so you can see it's a funny shaped piece of plastic, and the idea is that LED strip will shine against here, and this is kind of a diffuser that spreads the light out across it. And having seen these in practice, these work really well. They really light up very evenly, which is nice. And then behind that in here is just a very thin sort of white bit of plastic. So if I can get that out, yep, get that out like that, that comes out, and then you can put your own branding in here. Now, the official way to do that, if you're an alarm company, is you'd go to Texecom, you send them your designs, they would design all the graphics, get it all kind of templated and made correctly, and then you'd order custom inserts like this from Texecom and slot them into your sirens. But I found an interesting way to sort of brand it myself, and I think I'm going to do it, just kind of make up a fake alarm company, I don't know, put a sort of logo or something on here, just make it look a little bit more official. Now, I've not come up with a complete design yet, but I'll roughly talk about how I've done this. So what I ended up doing was I took this little insert out, I then put it in a scanner, and then put a bit of black card, I think it's used a bit of brown cardboard actually behind it in the scanner, just to differentiate it between the white of this and then whatever's behind it. And I scanned it into my computer. And I scanned it in A4 size, sort of 100% A4 size. I then pulled that image into my image editor, and then I was able to kind of trace around this image, pull that out and use it just to basically make a kind of an outline of this area. Then I could sort of draw my own design, put my own design into this area in my image editor, and then print it out at 100% size with no margins. Now, initially I tried printing it on paper, but it just didn't really work. You could kind of see the grain of the paper through the light, so it just doesn't look very good. So instead what I've done is printed on overhead projector film. So very old school overhead projector film, but it works. So I made this logo up. This isn't the one I'll use. This is just what I'll use for this video. I need to go away and actually try and use my terrible graphic design skills and design something a little bit better than this. But as you can see here, what I've got is I have the outline of that template drawn on, and then I've put my logo or my design in the middle. Now to print this out, I ended up using, first of all, I used a laser printer. I would definitely recommend using a laser printer, not an inkjet, just because this is potentially going to get exposed to moisture. A laser printer, an inkjet, it might end up running. With this laser printer, I printed it off on laser transparencies. I've run this under the tap. It doesn't smudge at all, so that's absolutely fine. I also had to run it through the printer a couple of times. When I first printed it, it was a little bit faint. It was fine, but a little bit light got through. So I just very carefully lined it up in the paper tray a second time and printed basically over it again, and that made it a lot darker. I also set it to the sort of absolute best quality setting, and I actually explicitly picked transparency as the paper type, just so it would use as much toner as possible to get a really dark image. And yeah, it worked. It's also worth mentioning this is a really old printer that's running out of toner, so you'd probably get better results if you had a better printer with full toner cartridges. But yep, that's what we have there. So now I have this little sort of template here that I can then cut out and insert into the siren. So let's cut that out, put it in, and see how it looks. There we go, so that's now cut out like that. So that will now slip into there. Put this sheet over the back of it, just to keep it safe and kind of diffuse the light, I suppose, because it's not white, obviously, you'd be able to see the diffusing layer through. So put that white sheet back in, put this piece of plastic back in here. More horrible squeaky noises, like that. That's now clipped in, and that's the end result. Now, obviously, this is not what I'm going to be using long term. I'm going to design something a lot better, as I said. And equally, I'm definitely need to get a new printer, because you can see there's a bit of smearing from the drum. It's a really old printer. It needs replaced, really. But yeah, especially from like a distance. I mean, right up close, you can kind of see maybe the printing's not absolutely fantastic. But from a distance, if that's up at the top of a building, that's going to look pretty professional. So yeah, that's the sort of how I've been able to brand the siren myself. So yeah, hopefully you found that useful. If you're ever planning on installing one of these, you can quite easily brand them. So yep, that's a siren. And with that, that's all the hardware we're going to be installing as part of this system. So what we'll now do is we'll jump into the garage, take a look at how we're going to install the panel, try and figure that out, get the panel installed, and then we'll start connecting everything up. Okay, so now it's time to get the panel mounted. So we've already seen in the previous video what we have here. So we've got some steel conduit in here for power, and this comes up to this fuse connection unit. That's one designed for alarms that uses a key switch rather than a physical switch, so it can't be accidentally turned off, but you can still isolate power to the alarm panel. I've got that here, and that's going to be powered to the alarm. Now, my original plan was that I would use this conduit coupler to basically connect this straight into the bottom of the panel. But as we saw earlier, because the panel steps off the wall, this isn't going to work without trying to do some sort of conduit bend in here that's just not going to really be very nice. So instead what I think I'll do is I'll get rid of all this cable and this coupler, and I'll just put a stuffing gland in the top of the fuse connection unit, a stuffing gland in the bottom of the panel, and just run a bit of flex between them, just a small loop of flex, and then we'll have the panel mounted here. So that should be absolutely fine. So the panel will then be on the wall here, and then to bring the cables down into the top, what I'm going to do is I'm going to install some sort of maxi trunking down the wall. That'll go up against the ceiling. I'll cut a hole out the ceiling, bring all the cables down into the panel, and then I'll fire seal that hole either with some sort of fire pillow, which is like a kind of intrumescent pillow you can kind of stuff in the hole and then take out again for future access, or if I don't care about future access, just some sort of fire foam or something up there to fill that hole. Because right now all the alarm cables are currently still hanging down over here, coming out the hole that feeds the network rack. These are all going to move, they'll be pulled back across the ceiling and then drop down into the panel here. So yep, time to get the panel on, get that new mains connection in, get that trunking installed, and then we can get everything connected. Okay, so now I've installed this maxi trunking on the ceiling, brought all the cables back through that, so I've pulled all the cables back from where the previous were down into this hole, and I've pulled in a couple of additional cables, including a network cable for the alarm, so that's a Cat6 cable that's going to go to the alarm panel. And then this black cable is a piece of Cat6 that will run through the garage for a camera on the front of the garage. Because I'm already going to run an alarm cable from the panel up into this maxi trunking and then along the wall and mini trunking for the garage PIR and the garage keypad. So given I want a camera at the front of the garage as well, I may as well run the Cat6 through the ceiling, through that mini trunking as well, and just take it in the garage. May as well just use that trunking for both the alarm and that Cat6. So that's what that black cable is there. That'll sit out the way for now. So what I now need to do is get the panel on the wall, get all these cables pulled through into the panel, and then figure out how we're going to neatly dress these in. Of course, there's an absolute ridiculous amount of extra slack on these cables, so I'm not going to try and cut any of that off yet, especially because the cables are all labelled right at the end, and if I cut them off, I'll lose the labelling. So what I'll do is I'll get the panel on, try and get all of these pulled through into the panel. I'll see how much slack I can neatly stash inside the panel or behind the panel, and then once I've got all the sort of slack managed, I'll then cut off the excess. So yeah, time to get the panel on, get the power connected into it, and then figure out how to manage all these cables. And with that, I've now got the panel installed on the wall. So yep, I've installed the panel up here, I've connected the power in as I mentioned, so I've basically put a stuffing gland on the top of the fuse connection unit, stuffing gland in the bottom of the panel, and just run a bit of flex between the two, so there's a little loop there. That's absolutely fine. Much easier than trying to get that conduit in where it just wouldn't have been able to go in because this stands off. So that's power going into the panel, comes up and then connects into the panel up here. Obviously the power's turned off for now. And then to bring all the alarm cables in, what I've done is I've brought them through the trunking, behind the panel, and then I've brought them out through a couple of grommets on the side here. What I've also done is I've left an absolute ton of slack on these cables behind the panel. So all behind the panel here is a big loop of cable. So there's loads of slack if there's ever needed moved in the future. And then when I connect everything up, I'm also going to leave yet another loop of cable inside the panel. Just so if anything needs rearranged, anything needs serviced, the panel gets changed in the future for one with a different layout, I've got plenty slack on all these cables. And then we've got the Cat6 coming in here, so that'll be terminated and then connected to the network module when that's installed. And then for the garage keypad and PIR, I've got this alarm cable here that goes back into the top of the panel. It's currently just attached to a big reel, but eventually that'll come up into the trunking, come out the side of this trunking, along a mini trunking, and then serve that keypad and PIR. So what I now need to do is try and work out how to dress all these cables as neatly as possible into this without making it a complete rat's nest. Now, I've seen some photos online where people do absolutely beautiful panels by basically stripping back the outer insulation all the way back to where the cables basically enter the panel, neatly braiding all the individual wires together and creating big looms of just individual wires. But I'm a bit reluctant to do that because while it does look absolutely brilliant, I worry about tracing those cables in the future. You know, if you've got a pair of bare wires here that then loop through a massive big loom, how on earth do you ever tell which cable they go to and therefore which room they serve? So what I think I'll do is I'll kind of loop these all around, I'll label up all the individual cables as to what they go to, and I'll maybe break the insulation sort of here and then have, you know, some exposed bare wires, but try and keep at least some of the outer insulation intact inside the panel, just to make it much easier to trace all the individual wires back. Likewise, these are all 8-core alarm cables, but I'm probably going to use 4 cores out of most of them, apart from the siren that uses 5, I think, maybe 6. So each of these cables will have a bunch of spare cores in them as well. So what I think I'll do for that is I'll neatly tie up all the spare cores and just tie them to the outer insulation of the cable at the point that the insulation's cut. And again, that way, if I need to ever reuse those cores, I can easily locate which cable they're coming from. So yeah, we'll figure it out. I have actually wired a couple of alarm panels before, but I never did them that neatly, and they weren't either as big as this or smaller plastic ones and didn't have this many cables going into them. So I know it was many years ago. So yeah, this is going to be interesting to try and figure out how to do this without making a complete mess of it. But well, we'll see how this goes. So time to go and wire this up, and then we'll see what I come up with. Cool, so a bit of an update on this complete rat's nest. So I've now cut back all the individual cables to be a bit shorter, leaving loads of slack on them, but you know, they're not like 2 meters long hanging from the panel. We've got our loop put in here, so I'll put a couple more cable ties on that to make it look a bit neater, but I've got a loop of excess cable here. And with that, I've now got the panel wired. So as you can see, it's kind of a balance of trying to make it look nice, but also still be maintainable. So what we've got is each of these cables here has the excess cores tied to it to keep them kind of neat. And then the individual cores I'm actually using are then coming out individually and going up into the PCB. So it means that yes, it isn't the prettiest thing in the world, but it's still serviceable to access all these wires without it being a complete rat's nest. But it also means if I ever wanted to, say, daisy chain something off of, say, the upstairs landing PIR, I can find that cable, find the additional cores, and then use those. So it's absolutely fine. So In terms of wiring here, what we have is we have the individual zones wired in here with a pair of wires. So this is the wires that goes to the end of line terminals on each PIR, and then it'll put the appropriate resistance across to say whether it's either an alarm condition, a tamper condition, or everything's normal. So on the left we've got living room PIR, kitchen PIR, and then upstairs landing PIR. Next up we have 12 volts, so each PIR needs 12 volts. So these two cables here, well, it's a bundle of 3 wires. We have the 12 volts, positive and negative to each PIR here. And then over here we have 3 keypad connections. So again, I've just got multiple wires going into each terminal. So we've got 3 keypads. Each of them has positive, negative, transmit and receive. So that's power to the keypads and also a data connection for the bus. So yep, that's all the keypads wired in there. I've stripped the keypads back a little bit further in so you can see we've got the zone wiring here, keypad wiring here, and then finally we have the bell box here. Now I've left this disconnected for now just because as soon as I turn the panel on, it's going to go into an alarm state, the whole alarm would go off, and I really need to get the whole thing completely programmed and tested before I want to connect the outside siren. Because last thing I want is for me testing this, playing about with it, getting it all configured, setting off the outside siren and driving my neighbours mad. So I'm going to leave this disconnected for now, and then once everything's set up, configured, programmed and tested and working, then I'll connect this up. The other cable that I can't remember if I mentioned earlier, we have here is labelled smoke alarm, and that's completely disconnected. And that's because right now in this house, we've got a few interlinked smoke alarms that were just installed by the builder. Eventually, and hopefully quite soon, what I want to do is replace those with ones from Eco, just a better brand, and then install an additional smoke alarm in the attic and one in the garage, and interlink them with the rest of the other ones in the house. So what I ideally then want is to have the one in the garage then linked back to the alarm panel, so that if any smoke alarm in the house goes off, the alarm panel gets notified and it can either notify us or it can set off the siren outside, so hopefully a neighbour maybe looks out their window and sees something happening. So right now that's disconnected, but this smoke alarm cable just goes out the panel and sits above the garage ceiling. So as soon as I install that smoke alarm, I can install a relay base on the bottom of the smoke alarm, and that relay base will connect to the interlink wire that goes between all smoke alarms, and it can trigger a pair of wires on this to trigger an alert that can then go into panel. So right now the smoke alarm feed's disconnected, but when I connect all that up, we'll take a pair of wires out of this and connect it to one of the zone contacts. I've also labelled up the sort of zones I've connected there just to get it vaguely neat, but yeah, pretty happy with that. It's not the prettiest thing in the world, but equally it's definitely a lot better than many other alarm panels I've seen, so yep, that's all connected up there. So what I need to do is go around the house and start installing all the different devices. In particular the bell box, you'll see there's currently a cable in here, but I've not even showed running that cable. I've already actually installed the bell box, so what we'll do now is we'll jump into me showing installing that on the outside of the house, which wasn't fun, it was a bit terrifying going 6+ meters up a ladder with a massive SDS drill. So we'll take a look at installing the bell box, and then what we'll do is we'll run in the house and install all the other components. I won't show them all, but I'll kind of show installing one of each type. So I'll install one PIR on camera, one keypad on camera, and so on. So, yep, time to get that bell box installed, and then install the rest of the devices. Okay, so now it's time to do the part I've been really putting off and not wanting to do, and that is installing the outside siren. So this is the one cable I haven't already installed because I ran out of cable when I was previously doing the cable run, so I just didn't have enough cable to do the outdoor siren. So we're running a new cable in for this and getting this mounted on the front of the house. I don't know how much I'll be able to film because I'd rather not mess around too much with the camera while 6 meters up a ladder trying not to fall to my death, but we'll see. I might try and get a little bit of footage here and there. And then also to install this, I've bought literally the most adorable fun-sized SDS drill. It's this little Milwaukee 12-volt thing. And this should be absolutely brilliant because I wanted an SDS drill for drilling through the wall because I'm going to need to do quite a big hole all the way through the wall into the house. And while I do have an SDS drill, it's a big mains-powered thing that is so heavy, the last thing I want to be doing is taking that 6 meters up a ladder. So I bought this little 12-volt thing. It's absolutely tiny, but it is like a real SDS drill. Like, it's pretty powerful, so really interested to try that out and see how well that works. And then I bought 2 massive super long drill bits that should hopefully be long enough to drill through the front of the house, through the cavity and through into the attic where I can then get the cable in. So before we go outside, we'll quickly jump up to the attic and take a look at the other side we'll be drilling in from because it's going to be a little bit tricky. Then we'll get the ladders out and try and get this installed. Okay, so here I am now up in the attic, and this is on the opposite side of the wall from where we're going to be installing that outdoor siren. On the front of the house there's this kind of apex sort of pointy bit in the roof, don't know what you call it. And this is one of the only areas on the outside of the house at the front where I can drill through and get straight into the attic. Everywhere else on the front of the house would drill into an upstairs wall where it'd be a bit harder to get the cable to. So my plan is to install a siren on here because then I can drill straight through and bring the cable straight through into the attic, run it through the cable basket I've already got installed that we've seen in previous videos, drop it down into the garage and get it into the panel. So hopefully I can just basically drill through and come into here. The only thing that's going to make it a bit awkward, you might be able to make out if I bring the camera in closer, is there's two pieces of vertical timber that run straight down to the centre of that end wall. And that's of course where the panels, the siren's going to be, is in the centre. So when I drill, I'll just need to sort of drill at a slight angle to try and miss that bit of timber, and then hopefully pop through that OSB somewhere, come into this area, and then get the cable in. The only other problem is going to be is physically getting into this area to get the cable through and pull it through and clip it. I have done it before, but it involved a lot of very awkward yoga to try and get through there, and then I did literally manage to get stuck, and it took me a good while to try and figure out how to get out again, so we'll see if I can do that. It'll be a bit of an adventure, but yeah. Hopefully I can drill at an angle through from the front of the house and pop out somewhere in here. But I will be 6 meters up a ladder. Let's try and not die. Okay, so I'm up a ladder now. This is a really stupid thing to be filming, but we'll try. I've got my camera on a neck harness, don't worry, I'm not holding it. So let's try and drill. So I'm going to drill a small hole first just to kind of get a sort of pilot hole, and then we'll use a bigger drill bit. But I'm going to kind of drill upwards so I don't get moisture in, and also drill kind of slightly to the right to hopefully avoid that bit of timber that's running vertically here. So let's see how this goes. That drill is pretty impressive. So, yep, time to get a much longer drill bit and widen that hole out and get it all the way through. Cool, and there we go, that's now done. So I've drilled it out with a longer drill bit. Didn't end up filming that because it was getting very awkward trying to fit the massive drill bit and the camera up here. But yep, that's now through there. So I've drilled through the outer brick wall and or block work, and then through the OSB on the inside, and then the other end of this is sticking out in the attic. So what I'll do now is I'm going to leave this drill bit in here because it's currently going through both surfaces, so it's a good fishing rod. So what I'll do is I'll go through to the attic, get the alarm cable tied on, and pull it out, and hopefully have the cable outside. So, time to go and feed that cable in. Okay, so now I'm up in the attic. I've now fed in another cable for the sirens. It's an 8-core alarm cable, runs all the way through a cable basket, drops down over there into the upstairs cupboard, and then once it's all in, I'll feed it down into the alarm panel. So, yep, that cable's in there. So what I now need to try and do is ridiculously contort myself all the way through there, somehow to get to the end where that drill bit's sticking through, and then tie this alarm cable on and hopefully pull it through to the outside. Okay, so I've now contorted myself into the most possibly ridiculous position I could try and fit in, all the way down in here. So that's the rest of the attic out there. So I'm completely stuck in here. That was not graceful to get into, and I don't know how I'm going to get out. We'll figure that one out. But in here, we can now see, here we are on the other side of the wall, and we've now got that drill bit sticking through from outside. So yep, that is coming through here. So it's through the block work and then through the OSB on the other side of the cavity. So hopefully what I can now do is take the alarm cable that I've pulled through here, wherever it is, there it is, tape it onto this drill bit, push it through the outside, and then you'll be able to pull that through to outside. And then I'll try and neatly clip the cable in here just to keep it a bit neat, but we'll figure it out. I ideally want to get everything done in here and then not have to come back in here again. I actually will have to come in another day just to do a CCTV camera, but I ideally don't want to be coming in and out of this area because it is not graceful to get in and out of this here. Because of course, you're trying to do it while also trying to stand on the joist without falling through the ceiling. Not fun. But yeah, let's try and get that cable pulled through, taped onto that drill bit, and pulled outside. Cool, so that's taped on there. I've had to kind of tape it, put tape on the drill bit, and then tape the cable on with separate tape and not tape the cable sort of on top of the drill bit, just to keep the drill bit the same thickness, if that makes sense. So it's not super secure, but hopefully it'll work. So obviously I can't really make this any thicker than the drill bit because that's a hole it's trying to fit through. But fingers crossed, if I'm very careful and lucky, the thickness of the tape is making it a bit harder to pull through annoyingly. I'll try and hopefully get that through the wall and then to outside. Cool, so that's pushed through. The drill bit isn't going through the brick on the other side. I'm probably going to have to go up and pull it from the ladder. But what I'm going to try and do is I'm going to try and leave a decent sort of loop of slack here and then still neatly clip the cables in, just so, assuming I can pull that out first time, I don't need to come back in here. So yeah, we'll try and leave a decent loop, clip all the cables on, go outside, and then hopefully be able to pull that cable out the outside wall. Cool, so there you go, loop of cable down there, comes up, neatly clipped all the way along here and all the way to there. So now I need to try and figure out how on earth I'm going to get out of here, and then we can hopefully pull that cable through to outside. Cool, so that's now drill bit now sticking a bit further out the wall, so hopefully if I pull this, yep, there we go, there's the cable. Thankfully that didn't break off inside the wall because I was a bit worried about that. So yep, that's the cable. Decent bit of slack hanging outside the wall, so now we can get the siren put onto here. Cool, so cable's now through the wall. There's 3 plugs in there, don't really show up on camera. I've got a few plugs in there, so then we can now get the siren installed. But before I do that, I'm going to just put some sealant in this hole just to keep it completely sealed. What I'm also doing is I'm keeping this cable taut, so that at no point is it kind of coiled up inside the cavity or going in and then going down and then back up. By keeping it taut, it's being pulled taut from the cable clip that's inside, so it means the cable's completely straight across the cavity and it's sloping downward to prevent any sort of moisture going between the two. So yeah, I'm going to keep this cable fairly taut, fill that hole, and then we'll get the siren wired in. So there we go, that's now installed on the wall. These are really easy to install because the way these slide, it makes it really easy to level it, so it's installed completely level. I'll then adjust the tamper screw here so it's touching the wall behind, so that means if it gets ripped off the wall it can detect that, all that sort of stuff, so that's great. And then I've got the cable coming through here and I've sealed that hole. I might put a bit more sealant in there, it's kind of moved, but I'll do that once it's all connected. So what I need to do is get it connected up. So what I'll do is I'll try and leave a bit of a loop up here, just in case I ever need to re-terminate it. And then I'll also maybe leave a bit of extra slack cable in here, just in case of any future termination issues. But yeah, let's get this connected up, and then finally we'll be done up the ladder. Cool, so that's all now connected up. It's a bit of a weird arrangement here, where you actually need to strip back the outer insulation outside of this enclosed area and then feed the individual wires through some like very thin slots in the seal. Although realistically, this is all still kind of enclosed, it's not going to get wet in here, and then this is just kind of a proper seal to stop the actual electronics getting wet. So, stripped it all back, left a little loop here just kind of keep the slack out of the way. It doesn't get in the way of the tamper or anything, so that's absolutely fine. So we've got that to kind of give me some slack for future maintenance. More slack sort of looped up in here, and then they're all connected up. So, colour coding is not super important. Basically what you do is kind of pick whatever colour code you want, but if you're installing on an existing system, kind of keep the colour codes consistent. So I think on this one I've got red and black are positive and negative, blue is bell, yellow is strobe, and green is tamper. And the only reason I'm saying that on video is so I can remember it when I go and wire the panels in. Now in here, there's also a switch to enable the battery. I'm not going to do that right now, just because it says in the manual that what you're meant to do is connect the battery up, then connect it to the panel and power the panel up. But it says to not really leave it more than 24 hours with the battery switched on here and it not connected to the panel. So because I'm probably not going to get the panel connected up completely today, I'm not going to do that. I'm just going to leave it off just now on the battery terminal, and I'll come up once the panel's ready and switch that over. But let's get this all sealed up just so it's nice and weatherproof. So yep, the little cover should then go over there. When that closes, you can hear it closing the tamper switch, so it is making a good contact. If it didn't close the tamper switch when you close it, there's a screw there, you can adjust that to make sure it presses it down. So yeah, that's all fine there. It's time to get the screw in and then get the cover on. Okay, so quick update here while I'm editing. I've just looked at this and I'm not a fan of how I've looped the cable in here, because the way it kind of is looping, it's kind of coming up from when it comes out the wall, looping over and then down, which means there's a very slight slope towards the hole in the wall. Now, this loop is actually contained within the alarm body, so it's not getting direct rain on it. However, if water were to run down the wall and hit the cable, it does kind of direct it towards the hole. Now, the hole's filled, it's not a complete disaster. However, I've still not had a chance to get up a ladder and even adjust the battery connection to enable the battery in the siren. It's just the weather's been really bad. So next time I'm up the ladder and I actually enable the battery in the siren, at the same time I'll go in and I'll readjust this loop. So it slopes down from the wall and then loops round inside the enclosure, just to get rid of that issue. It's probably not a big deal, but I may as well fix it while I'm next up the ladder. So just saying that on video that I will be fixing that, but I've not had a chance to do it yet, so that's why I don't have any kind of refilmed clip or a photo of it when it's fixed, but I'll get that fixed soon. Okay, so let's take a look at how we mount a PIR. So I'm installing this PIR in the kitchen, so I've already put the back plate up on the wall and then brought the cable through the top. You just have to drill a small hole in the top and you can bring the cable through. Stripped off a decent amount of cable here, and the great thing with these capture PIRs is there's plenty of space to stash excess wire in here, so all this excess wire can easily be stashed inside the PIR for future access. On top of this, there's also a good chunk of cable pushed back up above the ceiling, so if I was to take this off the wall, I can pull a good, decent amount of extra cable through. You really want to do that, you want to leave lots of spare cable, so if you ever need to change it in the future, adjust it, replace it, whatever, slightly move it, you've got enough slack to do that. So now we need to wire this up. So of course we don't need all these wires, we just need 4 of the wires. But what's also great with this PIR is because the terminal block is removable, you can very easily wire the terminal block onto the wires down here, get a much easier position to wire it, and then once it's all wired, just dress the wires in nicely, clip the terminal block in, and get the PIR installed. So I'll get this connected up, get the terminal block in, and then we can put the PIR in. And there we go, so that's the terminal block now connected in, so we've got the same as on the panel, so black and red are positive and negative for the 12 volts, And then A and D, which are the end of line connections, I've connected the yellow and green wires. So yeah, that's ready to go in. So we can just neatly dress this around into here, get the terminal block in place, and install the PIR. And there we go, that's it now installed. So as you can see, you basically just need to, you can loop the wires down and back up again. There's like a little bit of sort of plastic sticking out that you can kind of tuck the wires behind. It's only on the left, there's nothing on the right to manage the wires, but there's this space down the left that isn't affected by putting the PIR in. So yeah, you can now have those cables neatly in there, take the actual PIR itself, and in theory, that should just slot in like that, slide upwards. There we go, like that, and that's now installed. So now all we need to do is turn the screw in the bottom a quarter turn, and that PIR will be ready. Okay, so now let's take a look at how we install a door contact on the utility room door. Apologies for the background noise, tumble dryer's on and I can't really turn it off for this video, but yep, we're going to install a door contact on this door. So we've got the cable already here to go, and we've got the door contact, but I've had to commit an absolute crime probably against plasterboard by doing this. Now, let me explain. So the problem is with all these doors, this will be applied to both this door and the front door. Obviously completely around the door is just solid timber, absolutely everywhere. And there's no access above this part of the door. So the nearest place I could get a cable through was kind of bring it through the ceiling here. And as soon as you go next to that, it's just timber all the way around. Same at the front door. Now, my initial plan was just to sort of clip the cable onto the wall and kind of have the cable sitting on the surface, but it was just going to look a bit rubbish, so I thought I would try this out. How badly can it end? So what I've basically done is I've used an oscillating multi-tool to just cut a big channel out of the plasterboard, so out the ceiling, down the wall to here. Now I couldn't cut it right round the edge because there's a metal trim on the end, so instead what I did is I cut it down to this area here, drilled up from underneath at an angle to meet it here, so I can get a cable from in here through and out here, cut a slot out under here, and then I can mount the door contact onto the door there. What I can then do is I can feed the cable through inside this channel, use tiny little cable clips to clip it to all that wood just to keep it flush and stationary inside the wall, and then hopefully I'll just be able to fill over that with some sort of multi-purpose filler, and once it's sanded and painted it should look absolutely fine. I'm also doing initial testing here in the utility room because I don't care as much about how it looks in here. The front doors, it needs to look decent at the front door, but hopefully this will work out fine. So I'll try and get the cable clipped in there, get the door contact installed, then we'll hopefully be able to fill over this and hopefully it'll look fine. Obviously in this video we won't see the end result, I won't have time to let the filler fully dry and sand it and paint it, but hopefully it'll look fine. But yep, time to get that door contact in. Okay, so that's the door contact now connected. So unfortunately this door contact doesn't really have enough space to have loads of slack cable in. So what I've done is I've cut all the wires back up bar 4. So 2 of them are currently used for the end of line configuration, and I've just left another 2 wires just loose in here. So if I ever needed to change it in the future, either a wire got damaged or for some reason I had to change this from being end of line configuration to have like a separate tamper and alarm loop, I've always got the additional 2 wires here. So I've got 4 wires here and then 4 wires cut off. That'll be absolutely fine. So yep, that's now in there. Of course we can put the cover on that, the cable comes neatly out the top, it's all fine. So what I now need to do is just get this all filled. So as you can see inside the chase, I've just used a couple of cable clips just to secure it in. To put these in, I end up using a nail punch just to kind of be able to nail neatly below the surface that and cut a hole to plaster it to fit the head of the hammer in. So I've used a nail punch, put a few cable clips in, get that nice and secure. I've also put a few plasterboard screws or a couple plasterboard screws either side of the chase just to ensure that the board on each side is secure, because obviously I've cut through the middle of the board. So there was a risk of movement there, so I've done that, just completely secure those boards down, so hopefully when we fill over this, there should be no movement and it should work fine. So, yep, now what we need to do is just get some filler in here, get it all sort of as smooth as I can. We'll need to sand it down later, but that's fine. So we'll get some filler in here, get the lid of the door contact on, get the magnet attached to the door, and then this door contact should be complete. Cool, and there we go, that's the door contact now installed. So I've installed both halves of the door contact, and I've done a first fill of that chase. Now, it doesn't look great right now, but that's just the very first run of the filler. It's of course sunk back and cracked a bit just because it was a very deep hole. So that now needs sanded down once it's completely hardened, and then I can put more filler on top. Might require a couple of goes, might require some sort of finer filler on the top to get a good finish, but realistically, once that's sanded down and painted, it'll look absolutely fine. So, yep, that's the door contact now installed. Okay, so now next up, let's install the glass break sensor. So I've already screwed the back plate to the wall and installed the cable. So I've got a cable here that runs from the back of this, drops straight down inside the wall, and we'll go to a keypad on the other side of the wall. As I mentioned earlier, this was a bit of an afterthought, so I didn't put a dedicated cable going back to the panel, so I'll just run it off one of the zones on a neighbouring keypad. So now we just need to connect this up. And what's interesting with this one is that unlike the PIRs and door contacts, this is more of a traditional device in that it doesn't include built-in resistors. So we're quite fortunate here that both the keypad, the PIRs and the door contacts include the resistors. But if you're installing PIRs and alarm accessories traditionally without the built-in resistors, which is kind of how most brands work, you do actually have to install resistors like this. So with different alarm panels will require different resistor values. So with Texecom, what you need is a 2.2k resistor, which goes between the tamper contacts and the alarm contacts, and then a 4.7k resistor that sits across the two alarm contacts. And then when we connect the wires up to this, one wire will go to the other end of the tamper contact from the resistor, and then the other wire will go to the other end of alarm. So essentially what happens is, because these relay contacts for tamper and alarm are both normally closed, when tamper is closed and alarm is closed, so there's no tamper or an alarm state, the panel will read this 2.2k resistor. If the tamper circuit opens or the cable gets cut, it'll go completely open circuit and the panel will detect that. And if there's an alarm state, the alarm contact will open, which will put this 4.7k resistor in circuit. The panel will see that resistance, which will be 4.7k plus 2.2k, and it'll read that resistance and know that there's an alarm. So that's kind of how it works. If you want to figure out how to wire this yourself, there's a lot of wiring diagrams in the manual for the Texecom panel. But essentially what we have here is the 2.2k resistor between tamper and alarm, and then the 4.7k resistor across the alarm contacts. And then we connect the wires in. One will go to the one end of the alarm contacts, and then the other one will go to the other end of tamper. So we'll get the wires in and get this installed. And of course, this also needs 12 volts. I'm also going to try and leave a fair bit of slack inside this. So let's get it connected up and see if we can get this in. And there we go, that's now wired. So you can see we have the green wire goes into the opposite side of the tamper relay from the resistor, and then the yellow wire goes into the side of the alarm contact that's not got the two resistors into it. Then we've got 12 volts into the middle terminals there. So yep, that's all wired up. So now try and dress these wires in neatly, get this all reassembled, and then we can install the keypads. There we go, that's it all now installed up there. So next up, let's install a keypad. So this is the keypad in the utility room. This one has the most stuff connected to it, so I thought it'd be interesting to show on camera. So what we have here in terms of cables is we have the network connection that goes back to the panel, the cable to the door contact, and then the cable to that glass break sensor. And I've already stripped them back, labelled them up, kept the excess cores looped back so they're there for future access. So now we need to connect to the keypad. Now to mount this back plate to the wall, what I've done is I've used 4 just DeWalt wall dog screws, which are just special screws that can screw straight into plasterboard. And then I've used a proper self-drilling plug and screw for this screw here, which is part of the tamper protection system. So that again, if this is ripped off the wall, this is a very solid fixing, so that plastic should rip out the back of the back plate and trigger that micro switch there to put it into tamper state. What I've also done is I've set the dip switches here to set an address of this keypad. So this is keypad 2 on the system, so I've switched up number 2. Each keypad needs to have its own address. So now we can get this connected up. So the network connection, quite sensibly, will connect to the network connection on the back of the keypad. What you need to do is basically map directly the same wires and the same connectors as you do on the panel. You don't need to cross transmit and receive, which can be a bit counterintuitive. You know, if you've ever worked with like serial ports, you'll cross transmit and receive between the two devices, but on this you don't. You basically connect whatever color is connected to T on the panel, you connect to T on the keypads, and the same for R. You don't cross them over, which confused me at first. So yeah, basically map the exact same network connections as you do on the panel. And then for the zone connections, because we're doing end of line wiring, not double pole wiring, we just connect into the extreme outer terminals on each zone, and that should work absolutely fine. The door contact doesn't need 12 volts, so we just have the zone wires. The glass break sensor does need 12 volts, so that will just piggyback off the 12 volt connection on the network, just that plus and minus there. So yep, time to get this wired up, and we'll have our first keypad installed. And there we go, that's all now wired up. So network's connected in there, the 12 volts for the glass break sensor is also piggybacked off of that, and then the 2 zones are connected into the outer terminals on the 2 zone connections there. So let's get this back on the wall and carry on with the rest of the install. And there we go, that's our keypad now installed. So yep, that's on the wall there, ready to go. So I've now shown basically one of every type of component I'm installing in the system. Still got to install a couple other keypads, the door contact, an upstairs PIR, and do all the stuff in the garage. But what I'll do is I'll go away off camera, get all that installed, and then we'll run through all the hardware once it's installed, and then get the system fired up and programmed. Okay, so now it's time to look at the final thing we'll be installing, which is the keypad and PIR in the garage. So as you can see, I've already run the trunking in, so we've got some mini trunking that comes off that main branch, runs up and along the ceiling. Originally I wanted to run this along the wall, and I think I maybe said earlier I was wanting to run it on the back wall, but just with all this racking off to the side here, there's just no chance I'd be able to safely get in to install that, so it was just easier to put it along the ceiling. It's not my ideal choice, but it'll be absolutely fine. So I've already got all the trunking in, so it runs along the ceiling. Down here, I've installed these D-line fire clips that are screwed into all the joists, so it's completely secure and it's completely safe in the event of a fire. The cables will all be fire clipped in. So that then runs down the garage from here. It then carries further down along the garage, where round about here in the middle of the garage, it branches off into the PIR. Now, it's probably a bit of a hack I've done to mount this PIR, but essentially all I've done, if we take the cover off and remove the PIR module, I've just basically screwed it through and used just extra long screws that go through here, through the trunking, so the trunking is spacing it off the ceiling. It's probably not the best way to do it, but I'm just working with what I've got here. It's completely secure, and I've screwed it through the tamper bit, so if it did get ripped down, it would signal to the alarm. So the cable to it can come through the trunking, probably branch off somewhere here, and then go into the PIR somehow, and then the cover screws on and it looks completely neat. So that's PIR there. The trunking then carries on further down the garage, all the way to the end here. So if I carefully come down, we can see it comes down here, down around the corner, missing a corner piece there. I just ran out, so I just need to get another corner piece. Runs along here to where I've only just realised it goes completely off level, but it was very late last night when I was trying to install that, and I was also leaning over a fridge, so forgive me for that not being quite level. It then comes down here and then drops down here into the keypad. So what we need to do is, through this trunking, we're going to need to run 2 alarm cables. There's going to be one alarm cable that's going to come from the panel all the way around back into the keypad. Then another cable is going to come out the keypad, run back through the trunking, and that one is then going to come up to the PIR and run into the PIR. And then in addition to that, we've also got this black Cat6 cable here that's going to go to a camera on the front of the garage. So that's also going to run up through the trunking. This goes back to the rack. So that's going to run up through the trunking all the way down to the front of the garage. It's then going to run along here with the alarm cables. And then in this area here, it's going to branch off in that T-piece and branch off downwards. I'll just leave it coiled up for now. And then when I install the camera, what I'll end up doing is drilling through the garage wall round about here. And then I'll feed the cable out the garage wall there, and I'll probably have a bit of trunking that'll come off the bottom of that T-piece, maybe into some sort of surface back box just to put a little coil of Cat6 in it, and it'll go through the wall for the camera. So I'll get that cable in now, but I won't end up connecting it up. I'll just leave all the pivot coiled up here. But yeah, that's the cable route for the garage. So what I need to do is get those cables pulled in. We can then connect up the keypad and PIR, and then commission the system. Okay, so that's all now installed. So we can see we've got all the cables running through the trunking, round here, drops down here. So this black one here for the camera will come out that T-piece. I still need to put the bit of plastic back on. And then the alarm cables come down into the keypad, where we've got 2 cables. So we've got the network going in and then the PIR coming out. I'll get all the trunking lids on later, but I'd rather get the system up and running rather than messing about doing that. And then after all that, they'll then run up the trunking here, all the way along here, and then into the PIR that's installed up there. So with this, I might need to adjust the sensitivity on it because it's a dual tech, so it's got that microwave sensitivity adjustment, but I'll see how I get on with time, so yeah, we'll figure that one out. And then if we come all the way back round to the panel, if I try not to fall over everything that's in my way here, come all the way around the panel, we can see we have all the cables, once they get in, coming back down and into here. Okay, just jumping back in here with a slight change of plan. Don't quite know what I was thinking before. I clearly forgot wood existed as a material. So instead of that weird trunking bodge I did, I've just taken a little block of wood, screwed that to the ceiling, and then screwed this to that. And it's screwed through that wood as well, so it's securely attached onto the joist. Don't quite know what I was thinking about the whole trunking approach, just literally didn't think about doing this. But this feels a lot safer because I was a bit worried about the trunking approach where this tamper breakout area wasn't that well supported, so it could have potentially cracked off over time, whereas now that's on there, that's completely secure, there's no chance of that accidentally failing. So yeah, that's absolutely fine, ready to go. The only other thing I've noticed with this PIR that I forgot to do earlier is on this one, we saw earlier it has these kind of different dip switches compared to the sort of single switch select resistance. By default, this doesn't seem to have any resistances selected, so all I need to do is explicitly slide up the ones for 2K2 and 4K7, which are the Texecom resistances, explicitly pick those dip switches, and then we should be good to go. So yep, let's get this on the ceiling, and then we'll carry on with the setup. So now we can turn the panel on and start commissioning the system. So what we'll do is, obviously all the power is connected up, everything's connected and ready to go. So if I use the fish key, I can turn on this fuse connection unit and power the panel up. Now, as soon as I do this, the alarm's going to go off and it's all going to go into tamper state because the front's off the panel and these zones here aren't currently connected to anything, so these would go into tamper. Now, you can avoid these zones going into tamper by putting resistors across them all, but I prefer to just leave the resistors out and then just configure all these zones as disabled, and then that also does the same thing. But yeah, because it's all half not connected and stuff like that, it will go into tamper state. So what I'll do is I'll turn this on, run down to the keypad in the garage, put in the user code, which by default is 5678, and that'll silence the alarm. It's also worth mentioning at this point the bell box still isn't connected, so it won't be annoying my neighbours or anything. I like to leave this off until everything is up and running rather than connecting this and having the siren going off outside. It also means I can test setting the alarm off and everything without having any issues. So let's turn this on, then run into the keypad and silence the alarm. That's it firing up. And you can maybe hear there, it's now going into an alarm state, so if I carefully try and run down the garage without falling over everything. All the way down here. Here we have the keypad that's saying system alerts, so we put the key code in, which is 5678, and it's up and running. So it's given various states there: battery fault, tamper. It's very unhappy, but it's up and running. So now let's commission the system. So now that I've silenced the alarm, now let's get this thing programmed and configured. Now, you can the general way you normally commission these alarms would just be doing it from the keypad. You'd log into the engineer settings and do it all through the keypad. And the instruction manual does kind of show how to do that. Now, when you're programming these panels, it's not for the faint-hearted. It's perfectly possible to do yourself. When I first programmed a Texecom panel, I figured it out despite not having much knowledge about alarm systems. However, the instruction manuals, there's at no point is there a kind of quick start guide or a order you're meant to do the steps in. All it really does is have sections on configuring zones, configuring areas, configuring codes, and the manual sort of details the menu system for each of those, but it doesn't really tell you what you should be configuring. So it's a little bit tricky. Now, personally, while I don't mind configuring these from the keypad, I'd much rather configure these from a laptop running the Wintex application, just because it's a lot easier. Rather than standing over a keypad trying to repeatedly press buttons for ages getting everything configured, I can just download the panel's configuration onto a laptop, sit on the couch, get all the configuration done, and then once I'm configured, I can upload the configuration back to the panel. So that's what I'll do in this video. Now, this isn't a complete novice's guide to programming one of these, but what I'll do is I'll show how, first of all, I connect the laptop to the panel and download the configuration. I'll then go and configure it all off camera, but when I'm configuring it, I'll note down all the areas that I've changed the configuration in, so that then when I can come back on video, I can show roughly the configuration I've made, will then upload that configuration back to the panel, and should end up with a working system. Now, to connect a laptop to the panel, the official way to do it on a modern laptop with USB would be to use Texecom's COM-USB cable. So what you do is you plug that USB in into your laptop, plug the other end into the COM port on your panel, and you'll be able to connect it up. Now, because I'm cheap, I'm not doing that. Instead, I'm using one of these sort of generic TTL serial cables. These are pretty inexpensive on Amazon, and there's a good blog post here. I'll try and get that. I'll try and put a link on the screen if I can remember. But this shows how to connect a regular TTL serial cable up to a Texecom panel without having to use the Texecom COM-USB. The COM-USB is basically one of these with a fancy connector on the end that plugs directly into the panel. So on the COM port here, you've got 5 pins. One of them isn't used, so from left to right you have 12 volts, nothing, 12 volts, nothing, ground, receive, and transmit. So obviously don't connect anything to that 12 volts because you don't want to plug that into your serial converter. So when you've got your serial to USB cable, you want to plug ground into ground, receive into transmit, and transmit into receive. So you want to cross them over. So yep, that's mine connected up there. So this blog post kind of explains how to do it. But now with my with my USB TTL serial cable connected, we can now connect to the panel and download the configuration. So I'm just going to film the screen. I do apologise. I just really need to get this thing working. I can't be bothered setting up screen recording. What we're going to do is we're going to not save that. So we're going to create a new account in the Wintex application. So I'll just call this house. You have a new account per kind of panel or per configuration you set up. So we're going to add that account there. We're then going to edit the account. And there's a few bits of configuration we need to pick here. So first of all, you need to pick the panel type. If you get this wrong, it will not work. So this is an Elite 24. Software version is version 6, which we can see here is what the panel has on it. You could also probably check it through the keypad. UDL password. Now, this by default is 1234, so I'll leave it as that. This is like a password that you need to give to the panel to initiate serial communication. You can change this on the keypad as well, so you could change this password if you want to, and it's probably a good idea to do that, but by default it's 1234. So that's all set there, so that's all we should need to do there, so hit OK. We're then going to go to Setup, go to PC COM, and in here we need to pick the COM port that my USB serial adapter is connected to. So in this case it's COM4. You can check that if you just go into Device Manager on Windows. We can go into here, And through here, we will see that once it loads up, we have ports, and we can see there's my USB serial COM port, and it's labelled as COM4 in there. So now that's picked, we can then go to OK, hit connect, and hit connect using PC COM, and hopefully down in the bottom left we should see a connection happen. There we go. So it's now giving an error saying that my zone programming and the configuration stored in Wintex and the configuration on the panel are different. This is because I've tested this off camera. You may get this, you may not. So I'm just going to press receive data, and that's downloading all the configuration from the panel. If you didn't get that message, what you would do is you go to receive panel programming data, or you can even see receive all, but I'm just going to receive programming data, and that's going to download all the configuration from the alarm panel onto the laptop. So I'll wait for that to finish, and there we go. So I now have all the configuration of the panel stored on the laptop, so I can save the account up here, and then I can press hang up over here. And now I'm disconnected from the alarm panel. I can now unplug the USB cable, leave this account open, I can go away to the couch, go through here, I can go into all the areas, go to zones, pick all the different zones, go to the areas, pick all the areas. I can do the full configuration of the panel through this software, and then we can come back and upload it to the panel. So what I'll now do is I'll go away, get all this configured, I'll try and note down anything I've configured in here so we can quickly run through and show what I've set up, then we'll get this uploaded to the panel, and hopefully we'll have a working alarm system. Okay, so here we are in the Wintex application. I've already completed all the configuration I'm going to need to do. So what we'll quickly do is we'll run through each of the different areas that I've configured and talk briefly about the configuration I've set up. I won't go into complete detail here. If you want to find any more information about any of the options you see in this system, the best thing to do is look up the manual for the Premier Elite panels, and that explains each of those options and goes into full detail about what each option does and how to use it. It's the sort of thing that when you're using this, the Wintex application is great for showing you the different options and giving you good visibility of them all, but you really need the manual to get the full detail about how they all work. I still much prefer programming a panel this way versus using the keypad though, because when you do it through Wintex, you at least get clearer visibility of what options there are to configure. Whereas on the keypad, you just get a bunch of like little letters on the screen that you kind of then have to look up every single little thing in the manuals, try and figure out what to do. And there's been a few options I've found through Wintex where I've just seen an option and thought, what does that do? And it's actually turned out to be a really useful option to configure. So yeah, we'll quickly run through all this and take a look at what we have. So the first area we need to set up is all the zones. So what I did in here is I've gone through each of the zones. We have the 9 zones that are on, or the 8 zones that are on the panel itself. And each of the zones that are currently not connected, I've changed to not used. And that stops them going into tamper when the panel's powered up. As I mentioned earlier, you can instead put resistors across to make it think that there's a zone there and it's not in tamper mode. But instead, it's much easier just to disable all the zones by turning them to not used. Then we need to configure each of the zones that I have actually connected. So here we have the first 3 zones on the panel, which are the different PIRs. So with each of those, I've given them a name. So living room PIR, kitchen PIR, and upstairs landing PIR. And I've set the zone type to guard. There's a bunch of different zone types here that are available on Texecom. We'll just talk briefly about really the 2 that I'm using, which is guard and entry/exit. If a zone is set to guard, generally speaking, when the system's full alarmed, if someone walks into that zone, the alarm will go off immediately. So even if you come in the front door and the alarm's doing its nice little countdown, as soon as someone walks into the living room, the kitchen, the upstairs landing, the alarm goes off immediately. And that's the sort of thing you want, because if someone was to say break in by forcing the front door, you don't want to give them 30 seconds or whatever to disarm the alarm. You want it to go off immediately as soon as they go somewhere that they shouldn't be. The other zone type is entry/exit, which I've used on all the door contacts and the garage PIR. What that means is when you trigger that zone, so you open the door or you walk into the garage, it triggers an entry, which gives you 30 seconds, however long you've configured, to disarm the alarm before the alarm goes off, which you may also want. The option you've kind of got in between is guard access, which basically says that normally that acts like a guard zone. However, if an entry/exit timer has started, you are then allowed to walk through that zone. So you may have it, for example, if you've got a door contact on your back door that triggers an entry/exit, but then you need to walk through the kitchen to get to the keypad because you don't have a keypad at the back door like I do, you would set the kitchen to guard access, which means that as long as you've come in through the back door, you're allowed to walk through the kitchen before you trigger the alarm. There's a million other options here. Well, not a million, but there's a bunch of other options here for lots of different things. I'm not going to go into all the detail, things about panic alarms, fire alarms, medical alarms, all that kind of stuff. Not going to go into that detail, but it is all detailed in the manual. The other thing I've set up here is the areas. So we have 2 areas on this panel. Area A is the entire house and Area B is the garage. So for the most part, all these zones are set to area A, except for the garage PIR, which is set to area B. And that's kind of how I've got it working between the two areas. The other thing you might see here are these attributes. So we've got emittable and entry/exit 2 selected on a bunch of these different zones. And then this one here, which is the upstairs landing PIR, is set for part 1 emit. The way this works is on this alarm panel, you have 3 different part sets you can use. So I've currently only used one, which I'm just using it as a night arm. In the global options, you can actually name these. So if you go to global options system text, you can name your different part arms. So I'm only using one of them, so I've named it night arm. So if I want to set the alarm at night, I press the part arm button, pick night arm, press tick, and it sets the night arm. But you can have 3 of these. And then the way this works is you can pick zones that are emitted from these different part arms. So if I part arm the system at night, all the zones will be armed except for the upstairs landing PIR, which allows me to walk around upstairs at night and not set the alarm off. Then on these downstairs PIRs, we have entry/exit 2 selected. What this means is that if there's a part arm, the system is part armed, it's not full armed, and you walk into one of these zones, it will trigger an entry/exit countdown and let you disarm the alarm. So with this setup here, what that means is when it's full armed, if I walk into the kitchen or living room or go upstairs, it'll immediately go off. However, if I've set on a part arm and I come downstairs in the morning, forget to disarm the alarm, and walk into the living room or the kitchen, the PIR will sense me, it'll trigger as entry/exit 2, give me a nice countdown to go and disarm the alarm. And that's been working absolutely perfectly. Likewise, we've got the door contacts down here. These are all set as entry/exit zone types because we want an entry/exit to trigger if I open or close one of the doors. Likewise, garage PIR, that's also set entry/exit because I want to get a nice timer if I walk into the garage because I don't have a door contact on the garage. Once again here, we've got the glass break sensor, which again is a guard zone type. And then the only other thing in here that's maybe worth briefly mentioning is if we look at the garage PIR, we have the zone wiring. Now for most of these, it's set as end of line or double pole/end of line, which is where we've done it with the resistors. The garage PIR is slightly different in that it is a triple end of line device. I think it's because it's a grade 3 sensor. So essentially what it has is 3 different states, either alarm, tamper, or fault. On that PIR, there's just different dip switches for each of those values. So I've just set it triple end of line, so it means it can detect a fault. Nothing really any fancier than that at all. Now, the one thing you might see here is some of these zones have a little keypad next to them. And that's because these are the zones that are connected directly into the keypads. By default, when you set the panel up, these don't show up. What you get here is you get 20 zones, or the 24 zones that the panel has. If you have a bigger panel, you'll have more zones here. First 8 zones have a picture of the panel because they're hardwired on the panel. And then all the other zones have this little picture of a zone expander next to it, which would be an external zone expander that you'd wired into the panel. When you first set this up, these zones here, 9 to 14, also show a zone expander, and any of the keypad zones aren't available. So if you want to use any of the keypad zones, what you need to do is go into Keypads, pick the keypad. I've got my 3 keypads here, and on the right hand side here, it says zone 1 is mapped to and zone 2 is mapped to. So for each of the 2 zones on the keypad, you need to map them to panel zones. So you can see on my keypad 1, the zones are mapped to 9 and 10, keypad 2, the zones are mapped to 11 and 12, and so on. So once you then map your keypad zones to your panel zones, you can then come in, they'll then change this little icon here to a keypad, and you can then come in here and configure those keypad zones, because by default, the keypad zones won't work until you've defined them over here. The other thing I've set up in the keypad section is I've assigned all the keypads to different areas. And we'll talk about this in a minute. So we have the 2 keypads here, the first 2. This one, keypad 1 is at the front door, keypad 2 is at the back door, and keypad 3 is in the garage. And what you'll see here is keypads 1 and 2, so the ones in the house, are assigned to both areas A and B, so both the house and the garage, whereas the keypad in the garage is set to just area B. Now this is going to be a bit confusing, but I'll try and explain why I've done this. Essentially what I want is so when I arm the house, the entire house arms, including the garage. So if the garage is ever left disarmed, we go out, we arm the alarm from in the house as we're leaving, it also arms the garage. However, what I also want is when I come in from outside, I disarm the house, I don't want the garage to disarm, I want the garage to remain armed. So the best way I found to do this was to set both keypads in the house to areas A and B and enable quick arm. What that means is when I press the quick arm button on the keypad, it will arm both areas straight away. But how do I set it up so I can only disarm the house when I come in and that doesn't also disarm the garage? Well, the best way I could find to do that, and there might be better ways, so if you know a better way, please leave it in the comments, I'd be interested to hear them, What I've done is I've set up two different users on the system, one called house and one called garage. And these users have different codes. So the house zone, or the house user, is assigned to area A, and the garage user is assigned to area B. That means that when I press quick arm on a keypad in the house, it arms both areas, but when I come in from outside, as long as I enter the house code will only disarm area A, which is the house, leaving area B, which is the garage, completely armed. Then if I go into the garage, all I need to remember to do is enter the different code, so enter the garage code, not the house code. What this also means is I can easily arm and disarm the garage from inside the house. So I can go to any of the keypads in the house, and if I enter the garage code, I can use that to arm or disarm the garage. So that's pretty good as well. So if I ever was in the house, realised I forgot to arm the garage, I don't have to go out to the garage and use the keypad out there. I can just enter the garage code on the house keypad and it'll arm the garage. So yeah, that's how all the keypads are assigned to different areas and how I've done that with two different user codes. I need to add more users in here as well, but I've just currently got the house and the garage with two separate codes. And that's most of the user setup as well. There's not really that much to do here. Another area that's worth looking at here is the areas section. This is where we have those two areas, one for the house, one for the garage. So in here you can name them, so you've got area A, area B. If you've got a bigger panel you might have more areas, so I've just named these area A's house, area B's garage, and that just shows up in various points when you're using it. I've then also adjusted the arming modes. So area A is set to entry/exit, and this is a feature I really like, whereas rather than with most alarms that have just a timer when you exit, you don't have to press it and then rush out the house within 30 seconds or however long the timer is. The way this works is instead you start the exit, the alarm starts beeping, and then once you've opened and closed the front door, so once you've opened and closed the door, it then treats you as having exited and then arms the system. So it means you can take your time. If you open the door and you forget something and run back in and grab something, you don't have to try and rush and make sure you do it within the time limit. As long as you don't shut that door behind you, it won't arm, and as soon as you shut the door, it arms. So I really like that feature. But of course, doing that requires a door contact to see that the door is open and closed. So because the garage doesn't have a door contact, it's just got a PIR, I can't really use an entry/exit arming mode. So instead I've just set it to a timed exit, which gives me 30 seconds as set here. So it's a 30-second exit delay time. So that lets me arm the garage, close the door, wait 30 seconds, and the system will arm. But yeah, that's most of the configuration in here. Now, there's a bunch of other options you can set. So things like the bell delay time is how long between an alarm going off and the outside siren going off. So if you wanted to, for example, have the alarm go off internally and maybe signal to a remote centre or notify you, give it a minute before the outside siren goes off, that's an option you can set up here. You can also set up the bell duration, so how long the alarm will go off for. You can either set that up on a per area basis, or you can go into global settings. And in the global settings, you can set it up here, so you've got a global bell duration. There's so many options. I mean, I'm not even going to go into all these, but you can just see the sheer amount of options here. All I'm trying to go through now is really the interesting ones that I've changed that would be useful. Most of these are generally set as default. So yeah, I'm not going to go into absolutely every option here and explain it, but that's kind of the options that I've particularly set here. So now with all the configuration there, let's get this saved and go out and upload this to the panel. Okay, so now with the configuration all made, we can now connect back to the panel again as before, once again connecting over the appropriate COM ports, so we're already connected to that. And then basically, as you can imagine, you would send panel programming data, hit yes to that, and that's going to re-upload all that configuration onto the panel. So once this is done, the panel will take all the configuration and should work as expected. I've also connected the battery because it was complaining about battery fault, so I've put that in there, and that should also stop complaining about the battery fault. So now with the configuration uploaded, everything should work. So let's check it out. So now with that configuration uploaded, it all works. I'm not going to go into too much detail and bore you to death showing all the intricacies of how this all works and how I have it all set up, but I thought I'll quickly demonstrate how I've got that arming working between the garage and the house, because that's kind of a bit different, a bit interesting, if you're interested in that. Anyway, not very interesting, but anyway. So here we have the keypad that's in the house. This is the one at the front door. We've got the other one in the utility. Both the front door keypad and the utility keypad work exactly the same as each other. So these keypads are assigned to both areas A and B. So that's the house area and the garage area. Now, right now, this is completely disarmed. If I were to enter the house code here, and then arm it, it would arm the house. If I enter the garage code here, it will arm the garage. Likewise, if the garage is armed and I enter the garage code, I can disarm the garage from here. So it's good having these keypads in the house, allowing me to control the garage as well from within the house. So if I forgot to arm the garage, I can come in here and do it. Additionally, I've enabled quick arm, which means that this button here, or the one that says area on the other keypads, will automatically arm all areas that this keypad is assigned to, which in this case is both the house and the garage. So if I press quick arm, it'll arm the house and the garage at the same time. But because my user codes are separate between the house and the garage, if I come in from outside, the whole house is armed, enter the house code here to disarm the house, it will leave the garage armed, which is exactly what I wanted. So we'll take a quick look at that working. So right now I'm going to press the area button. That's going to arm everything. I'm going to open the front door, close it again, which will trigger the door contact. And that's going to trigger the exit on that. So as you see, it's now saying that's now going to be arming the house and the garage. So that first noise there was saying the house is now armed. It's still arming B, which is the garage, because the garage has that exit timer, so it waits 45 seconds for the garage to arm. And with that, everything's now completely armed. So the house and the garage are both armed from pressing that one button. What I'll now do is I'll open the front door again to simulate coming in from outside and disarm the alarm in the house by entering the house user code. So let's try that. Don't know why I locked the door, that was silly. So now it's area and entry is A, so just the house is an entry, so I'll enter the code off camera. And now that's disarmed the house, but it now says part armed because the garage is still armed. So yeah, that's actually worked exactly how I wanted it to. Next up, we'll take a quick look at the garage. So as soon as I open the garage door, I'll set off that PIR. So garage door's open, PIR, as soon as I walk in, the PIR has now detected me. There we go. And now enter the code over here. So I'll just do that again off camera. Oh, nope. Oh, yeah, there we go. So now I've entered the garage code on here, and that's disarmed the garage. And likewise, when I want to arm the garage, I press area in here. That's now going to say area and exit B, so it's only arming the garage now. And then wait 45 seconds, and then the garage will arm itself. Likewise, inside it's saying area and exit B. So all the keypads do go off when the garage is being armed. And now with that, it's gone part armed again. So that's working exactly how I wanted it. Pressing quick arm in the house arms both the house and the garage. If I disarm just the house, it just disarms the house, leaves the garage armed. And if I press quick arm in the garage, it just arms the garage but not the house. It works perfectly. So there we go, that's everything installed and ready to go. Still need to get all the trunking lids back on and also fire seal that hole, but I won't have time to do that in this video, so I'll do that off camera and it'll be done hopefully by the next time you see this. But yep, that's everything up and running. So there you go, that was a look at installing my Texecom Premier Elite 24 burglar alarm system. And it went really well. Really happy with how it's turned out. I'm very glad I've been able to get the arming working exactly how I wanted it between the garage and the house. That's exactly how I wanted it to work. The Home Assistant integration works, that's really, really good to see. I'll probably show more of that in a future video. But yeah, it works really well. Now, what I would say with this is if you're want to buy a burglar alarm system, these Texecom systems are absolutely brilliant, but they're not for the faint-hearted. Don't buy one thinking you can just take it out of the box, there'll be a quick start guide in the box that you'll follow and get it all working. It's not really like that. As you've seen in this video, there's a lot of configuration, and while the manual does document it, it really just tells you how each area of the setup works, but doesn't tell you what settings you actually need to configure or in what order you need to configure them. It just kind of says, right, to set the zones, here's all the options for zones. To set the areas, here's the options for areas. But it doesn't hold your hand at all. You know, these are really designed for professional installers. So you definitely can install them. There's a lot of content online with people helping each other get these working. Hopefully this video has maybe been of use if you are trying to do this yourself. But just bear in mind, if you do want to get one of these, you are going to have to learn quite a bit about how to configure these, because even though I've configured these before, I had to kind of refresh myself quite a lot to get this up and running. But yeah, really happy with how it's working. So yeah, hope you found it interesting. All I've said now is thank you very much for watching.